Okay, you can load your terminal and the location where you have saved the file. So I will run the Jupyter Lab. Data files we will use at the end, so you can download that, keep it in the same directory where we download the X-ray data file. Like yesterday, I sent you another 2 files. No? At that time, I said like the download links were like not working right now. So I have downloaded those data that we require to run the script. So you can like download that data as well. Since it is taking some time, we will continue with the CartoPy at the very first beginning, and then we will discuss about X-ray at the end, how we can like use all of these libraries. So because now you know do 2D plotting like with your normal data. Now we will discuss about this X-ray CartoPy library, because we will use this for spatial mapping. So when it comes to spatial mapping, why we are using this one? If we need to do like 3D coordinate of earth or 2D coordinate of a figure, we can use CartoPy library. Actually, this one is replacing like previous library. Some guys will be familiar, like if they getting some course from their friends or their like supervisors, you will see one library called BaseMap. Actually, now this basemap library is outdated, so CartoPy is replacing that basemap library. So that's why we discuss about this one. We are not discussing about basemap. So first thing, since we are discussing about spatial plotting, you need to know about projections, because now we are going to work with projections. So typically what we are mean by a projection is like we are either showing it on a screen or a paper. That means we are projecting it on a flat surface. So it is like this for spherical. If we take like our Earth as a sphere, if you can see like this is an orange. If it is like peel this one, like after drawing the label, if we peel, map will be something like this. So we have a default projection for these kind of scenarios as well. But the map that we see is flat. Typically, we see the map like a flat map with all the continents and the countries. In addition to those maps, we have some other projections. So now for the basics, you can like visit. This is the original repository of the CartoPy library. At the very first, I say every library should have their own repository where they discuss about like their library and all the updates that they are going to give for this library, and even gallery. If you go into the gallery, you will see some samples how you can use this one to manipulate the data, and then if you go on the installation, they will show you the installation instructions. So you can go to that site and learn more about this one, because we cannot discuss all the things like in detail in a single class. Today we will discuss only about the basics, how to load the map and how we can change the projections. So here it is actually using PROJ project O library and NumPy library and Shapely library. So here we discuss about NumPy library. So these two are the other libraries which are included in here with the CartoPy. So when you are dealing with transforming lines, vectors, polygons, images between those projections, you can use CartoPy. And then how we can load CartoPy at the very first time. So this is the library we need to call for CCRS. So CCRS mean in short form CartoPy Coordinate Reference System. So whenever we need to assign a coordinate system or change the coordinate system, we need to call for CCRS. So this is one package included in CartoPy, because here we imported as cartopy.crs as then CCRS. So then also we are importing the entire library in the CartoPy as well. So after importing this one, first thing is we need to create a plate carrier projection, which is available in CCRS. That means CRS library. So why we are calling this one, you can go into the document. If you go into the document, so this thing is also updated. I think the link I have to replace. So if you go into here and check for the projections, so if you go for this function, you will see it is creating a base map for us to plot data. No matter what, we can put any kind of spatial data in a plot like this. When it comes to the projections, we have Albert equal area, and then we have azimuth equidistance, because you see some maps like this. So we can put like if you are dealing with like polar, that means northern hemisphere or like southern hemisphere, like two polar sides, you can use some sort of map like this. But typically we are using this map, and then we will have some other additional plots that we can use. So there are some default formats for these plots. Whenever you need to call for this one, you need to call for CCRS and then your projection type. In here, we call for the default option, which is the flat map, as we know. So we are calling for this one. Whenever you call for this one, we will call for this flat map. So what will happen after we call for this one? Nothing will happen, but it will assign this one as CCRS. So here you can see the default map. So now, but how we can like draw something in this map? To draw, we have to use, no matter what, we have to use. Yesterday, we like at the very like first time we discussed about matplotlib, we say we can use PLT to create plots. So we have to use matplotlib. The advantage is inside of matplotlib, if we call for like projection and some other data, some other kind of like spatial data, if we give the values, then matplotlib will automatically understand and convert this one into matplotlib understandable data type. So we don't need to assign like, okay, latitudes are this, longitudes are this. We don't need to say, okay, if we set the projection and everything, it will automatically be corrected. So you know about this one. When we run matplotlib in Jupyter Notebook, we need to run this magic command matplotlib inline, because then it will display the outputs in line format. So now we are calling for matplotlib pyplot, because we discussed about this one during the matplotlib session. So now we are loading that plotting library as PLT, and then we are saying plot access projection CCRS plot carry. So when we type this command, you can see now it has been changed into geoaxis. So if we didn't type this one, what will happen? If I didn't type this one and execute, you can like remove this part of the equation and run. So it will be a default like axis. But if I type this command in PLT, axis, what will happen? It will convert it into a geoaxis. So now we will have our plot area with two geoaxes. So now it understand, okay, we are going with the geospatial spatial plotting. Last time when we are creating plot, we didn't mention anything in here. But this time we are saying, okay, projection equal CCRS plot this default projection type in the CartoPy library. So now in this case, we can have multiple axes as well as we discussed last time. That means subplots. We discussed during the matplotlib, we can have a variable called AX, and then we can call for multiple subplots. In like we can divide our map space, and then we can create subplots. One subplot here, another, like 4 subplots like this we can plot. Now you know, in one subplot we can put a scatter plot or line plot. Another subplot we can call for spatial plot. Same way. Whenever you need to call for that one, you need to label your axis to be in this projection. Then it will understand, okay, you are going to focus on spatial plotting. So in here, we have some other additional features which is inbuilt into the CartoPy library. So last time when I called for this function, you see a blank map. I call for plot axis, then the projection, then I call for this function, projection type, and then it understand, okay, recognize this one as geo axis and create a blank project, blank drawing area. Now how I can add like some sample data. So in Matplot, in CartoPy, there's an inbuilt library. So you need to call for your subplot dot coastlines. If you call for coastlines, what will happen? There's free data set called like natural earth. Over there you can get coastline data scale to this value and you can show these coastlines in your map. If you execute this one, you will get this kind of output. That means it is downloading the feature data set automatically in behind and showing the coastlines in your map. This is the command that you have to put whenever you need to show your like region of interest or something by default. Otherwise, you can load it using a shapefile. But in this case, if you don't have a shapefile, you can default by default like the default coastlines to show the background in your map. And then the same thing, we can call these two together, figure AX plot subplot keyword projection, CCRS, carry, and then we can say AX coastline. These two are the same, not two different commands. These two are same commands. So if you execute this one also, you will get the same output. And then same thing, if you check on the docstring of this one, what it is saying, it is saying the abstract class which denotes a cylindrical projection where we want to allow values to wrap around. So this is for the cylindrical projection. So what does it mean by cylindrical projection? If we if this is the globe, and if we wrap a cylinder around the globe, this you can imagine this thing as a cylinder. So if we wrap a cylinder around the globe, and if we divide this, like if we cut open this cylinder, we will get a flat map. So that's what we call cylindrical projection. And we will have some conical projection. If you know about this one, if the Earth is like a globe, if we consider as a globe, we will have some conical projections as well. You can read about these things. And you need to know, okay, what are the other projection types available inside this library. So in here, if you need to center somewhere in your area, like just imagine if you know the center longitude or center latitude, you can center it accordingly. Last time I didn't mention in here, I only typed plot axis and then I assigned the projection type as CCRS plot carry. But inside of these two, I can assign central longitude. There's a variable called central longitude because in the docstring it should mention. If you check on the docstring, it is mentioning that you can assign a central longitude. If you assign the central longitude, it will focus on that longitude. Now I am saying central longitude as 180. So now it is focusing on 180. Here if you check, you will have the 180 degrees around here, the longitude line. So that's why you see map has been changed, because previously our map was like this. That means minus 180 was here and positive 180 was here. If you check on the longitudes in the map, in the typical map, you know longitudes are ranging from minus 180, then 0, 180. So if we call for this function without changing anything, what it is doing is it is taking the center line as 0 longitude. So that's why you see a map like this. But if you need to center it in another longitude, how you can center it? You can change the longitude to be whatever value you like. So if you type 160, you should be see this line like should be like centered in your map. So if this is centered, now you can see that line has been centered in this map. So this is the way that you can center your map according to your longitude. So next one, some of other useful methods when we are focusing on the geo-axis. So that means what are the other parameters that we can set for this age? So here we discuss about only about the coastlines right now. But we can set some other parameters like set global. If you set global, it will zoom the map as much as possible. And then if you set the extend, it will zoom the map into the given bounding box. And there are some other options like grid line. If you turn on the grid lines, what will happen? Grid lines will be appeared on this map. And then coastlines, we discuss how we can add the coastline. And then we can add stock images. That means we can download some images and plot over there. If we have some satellite images or anything, we can load and show it in the same map. So if we are going for to do something, we can call for stock image and then add that image and overlay in the map. And then we will have image show. So this is also if whenever we need to display a NumPy array or anything, we will use this one. Typically, we are using this IM show when we need to plot some data in the map. And then the next command will be add geometry. So whenever if you need to add a shapefile or something, then you need to call for this add geometries function. So if you go over there, oh, still it's not there. Let me update these links and share with you guys. If you know these things, we can go ahead. So from here, last time I only obtained one projection. Last time I say we have multiple projections. So if you go into the description and check for this function, you will see we will have multiple projections. So here we have one projection and then we have another projection. So how we can load multiple projections? So what I am doing in here? From here, what I am doing? If you understand the command, you know starting point and ending point. What I am creating a list. No. Here I am creating a list. I am creating a list. In my list, what I am passing? I am passing the projection system, different projection system. For the projection system one, I am passing what we call the cylindrical projection system. And then for the second projection system, I am passing Robinson. And for the third projection system, I am passing Mercator and then orthographic and interrupt geohomology. So how I can view these multiple projection types? So if I type this one and continue this loop, now I am looping through for all the project. That means it will create one as like 0 to it will loop through. So this is the looping variable and this one will be my array. So I am saying go through each of these individual projections and display me the output. Now for the output I am creating the figure and then I am passing axis. When I am passing axis, I am saying okay, this is the projection type should be whatever the projection I mentioned in here, and then dot the stock image. If I call for the stock image, now you will see an image was added into the maps, and then I am adding the coastlines, and then I am setting the title as the projection name. So if I run this one, what should happen? I should get these 5 projections in different maps. So if I execute this one, you will see I should have like 5 different map types. So now you can see the first projection type is this plate type. That means the cylindrical projection system, and then we will see the Robinson projection, because you will see this kind of maps when you are reading research papers like global temperature or global precipitation. When it comes to, you will see this kind of Robinson projections, and then Mercator, and then we have orthographic projection, and then we have the projection that we discussed, interpreted homos line projection type. Now these are all the projection types we can see inside this library. So these are all the projection types that you can use. So if I execute this one, it is also the same thing. It is looping through each and every individual projection and showing me all the projection types. So now you can see all the projection types which are available over there. So this is the first projection type, then the Albert equal. So whenever you need to create this kind of map, first where you have to change this one, you have to import CRS from the CartoPy library. Then if you import this one as CRSS, then you have to call for CRSS dot, then you have to call for your preferred coordinate system in here. So next command will be your preferred coordinate system. If you need a map from this kind of projection, because we discussed CRSS mean CartoPy projection reference system. So now you know how to set a reference system. So now how we can set the extent, because you know when you are doing your research, you are not focusing on the entire globe. Sometimes you will focus on a specific location. So how we can set this parameter, that means how we can zoom into a specific area. When we are zooming into a specific area, that means when we came to the regional maps, we have an option called set extent. I discussed about this one as well when we are discussing about in the above sections. So when we call for our plot, that means AX, then we can set the extent. So if I check the docstring of this one, you can see it is setting the extent. That means x0, x1, y0, y1 of the map in given coordinate system. If no CRSS is given, the extent coordinate system will be assumed to be geotic version and it will get the by default version. And then here you can see I am saying central longitude, central latitude as -10 and -10 and 45. So the center point of my map should be this specific location. Because if you go into Google Map or anything, you will see when it's come to maps, we are representing all the places in this map as X and Y. This is like, you can imagine, this is a huge X and Y line. If I click any area in any place in this map, I will have a point and then it will display me two values. So first one will be the latitude and the second one will be the longitude value. Even if I check on this line, if you can see the entire line in here, you can see over there also they mention the specific latitude and longitude which you are focusing on. So same thing goes in here. First we need to set the center location and then we can set the extent. So in extent, in here what will be the values? So x0 will be this place, x1 will be in this place, and then y0 and y2, y1. What is these values meaning? x0 means what value? First longitude. Because if we discuss about like these axes as x and y, this will be the x and this will be the y. So these are what we call longitude, and these are latitudes. Latitudes are ranging from -90 to +90, and longitudes are ranging from 180 to -180 to +180. Sometimes you will see this is ranging from 0 to 360. So in here now we are centering for this specific location. So now if you need to center for your country, how you can change this one? So then rest of the code is same. In here I am calling for the plot function. For the axes I am setting projection as orthographic coordinate system, and I am assigning the center value. I am passing the center latitude, and then I am setting the extent, and inside the bracket I am saying okay, this is my extent, and then display grid lines and display coastlines. So in this type, this time I am saying for display coastlines in 50-meter resolution. We have higher resolutions as well. We can go till 10-meter resolution. If you are focusing on a small area, then you can set 10-meter resolution. So now grid line is these lines. You can see these are the grid lines. That means grid line means latitudes and longitudes. You can like display those latitudes and longitudes in the map. Now these things are not labeled. We will show, like I will show you how to turn on the labels in here. But now you will see grid line is appeared. If I display, like if I didn't run this line, what will happen? I am not saying I don't need any grid line. So it should automatically turn off all the grid lines and give me only the map. So if I remove this part, what will happen? If I remove this part, now I am not setting my extent. If I execute this one, it should display me the entire world. So this is the projection system that I am focusing on right now. And now from this command, I am setting the extent, which I am interested in. And then from here, I am setting the grid lines, turning on the grid lines. So how you can focus on your country based on this? So here you have to set your longitude values. That means the first longitude value, and then the second longitude value, and then you have to find for first latitude value and then the second latitude value. So how you can set this one? You can try to set this if you know about the boundaries where your country is located in, because you know, if you know this x1 value, x2 value and y1 value and y2 value, what will happen? So if you draw lines, you will see it is automatically creating a box. So it will display this area in the map. So now you can try to do this one and check for, try to like center your country in this map. Try to center your country in this map. How you can like find the latitudes and longitudes? You can simply open the Google map, and then if you click, last time I mentioned, if you click on one corner, what will happen? It is giving me these values. So x value is, I say first one is latitude, the second one is longitude. So I need to check for the longitude value. So first longitude will be 79. And then if I click here, and I know from here I can check the latitude value as well. So you can save these values in a text file or something, or you can directly type. So here this one should be latitude 1 and this one should be longitude 1. And if I click here, in this area I will check for second longitude value. That means 82 point something for Sri Lanka. For your country, you can do the same thing for your own country. So in here, my second latitude level will be 10.12. So like this, you can check for these values, latitudes and longitudes. You should like need to get 4 values. You have to get first longitude value, then second longitude value, and then first latitude value, and then third second latitude value. So you need to get these 4 values. First I will click on the right side of this, in my right side of the country, then I can get the value as 79. So I can get my first longitude level as 79.23, and then for the latitude level 1 will be 5.46, and then for second longitude I can place in here, and then I can check it is around 82 something. So I can say 82.34. and then for the second latitude, to find the second latitude, it should be goes around here. So I can click somewhere around here and check for the first value. It is around 10.26. Now you need to type these values. For your country also, you can like open your map and then zoom into your country and check for the leftmost coordinate and get the values, and then rightmost coordinate and get the value, and then you can go to the top and check for the value. So if you set these values in here, it should center for your country, and here I am asking about the central latitude. Central latitude and central longitude as well. So if you're going to set this one, you can set. Otherwise, if I didn't set, what will happen if I remove these two? If I remove these two, it's not going to center for a specific place. It will give me the entire location. So now I will set the values for Sri Lanka for you. You can check for your country and set this value 79.23, and then the second value will be 82.34, and then rest of the values will be 5.46 and then 10.26. So you can see now it is zoomed into the area, but the problem is I selected the projection system as orthographic. So if I need the cylindrical projection system, what should be the command in here? If I need to check on it on a flat map, where should I need to change? In here I have to change this one for this projection type. So same thing you can do for your country as well. Try to do it, because most of the time if you are doing a research into your country, you will have to create a map like this. So here you can see, now you can clearly see, if I set this one as 100 meters, what will happen? If I set 100 meters in here, for coastlines, resolution is 100 meters. If I set coastline resolution as 100 meters, what will happen to the map? So you can check this one as well. Oh, so 100 meter is not there, 110 I think. 50 is there, let me set the 50. So if I set 50, you can see coastal line is not that much accurate. But if I set the value to be 10 in here, now if you check on the map, you can clearly see the coastline. So these are some additional features. You can try to do this part. Try to set your extent and like check, zoom into your country, because these are the basics. Then you can load data or anything into this map. So you went for the, I think you went for Google Earth, no? Go for the Google Map. If you go for the Google Map, then you can find. There are some other additional ways that you can use this one. There's one application called Google Earth. If you install Google Earth in your PC, then also you can get these values. I discussed like regarding Google Map. So best way is to go for the Google Map and get it from there. And if you have installed Google Earth, this one, this application in your map, then you can directly go into your place and put a place marker. From here you can get a place marker, and it will drop the place marker like this, and from here also you can get the values. If you drag this line, you will get the values. If I drag this place marker around the map, you can see here it is giving me the values. So this one I can change from the options. I can set this one to be decimal degrees, and I can apply this one and put the pin icon. I will apply OK, and if I put the pin icon, now I will get the values in decimal. So all of you have done this one, because this is the very basics. So these are very basics of CartoPy. Now we didn't plot any data, but you know how to set the background. After setting everything, you can import your data into the map directly. So this is the way that you can like customize your map. First you have to set all these things, and then you can load the data. So for the short command, when you are putting a comment, there are some short commands. Just imagine if I need to comment this line, I can use control and backslash. You can type CTRL plus this one. If you type these two key combination, it will comment. Even for one comment, you can go to the same line and hit the same two short keys, it will uncomment that line. So now, what are the other additional features that we can add? Because in CartoPy, there are some other additional features that we can add. Instead of coastlines, we have these all the features like country boundary, like country borders. So in this map, if I check the entire area, let me remove the extent. Let me comment the extent. So if I comment the extent, it should give me the entire map. So if I check for the entire map, this is the entire world. Now countries have not been separated. No, in here countries are not being separated. Only the coastlines are there. But if I need to separate using the countries, there's a feature called border. So if I call ax.borders, what will happen? It will load, like in CartoPy library, there are inbuilt functions. From there, it will load all the country boundaries and display in the map. And then if I need to, this one we discussed, we include the coastlines. If I need to display the lakes, I can use this command. If I need to display only the land, so this will be useful when you are doing land masking or ocean masking. So just imagine in your case, for your data, you will have the data for both land and sea. But for the final output, you need to display it only for the sea area or for the land area. Then we need to do land masking or sea masking. So for that thing, we will use this land and ocean option when we are doing some sort of masking. So this is to display the land area, this is to display the ocean area. And if we need to display rivers, we can use this option. And even we have one thing called this states, but the problem is it is limited for the US. For other countries, we don't have the states or like subdivisions or other kind of things. So what we can use, we can load our own shape file into our map. These are like default options that we can use without adding any custom data. These are like inbuilt. So in here you can see default features are at coarser resolution, that means 110 meter. So if I set, right now you see it is like much denser. So if I go for like huge area, I need to change the resolution to be in higher size. So if I set 110, you can see now it is much more clear. But if I put 10 meter in here, what will happen? Some areas it will be dense and you can see it is like bold. So if you are going for higher, like if you are going to view a big area, then you have to decrease your resolution. But if you are focusing on a small area, you have to increase your resolution. So what are the default resolution levels that this one has? 110, 50 and 10. 100 meter, 110 meter, 50 meter and 10 meters. So now we can go ahead and display this all the things that we discussed. So here first I say we need to import CF features. In here, whenever you need to call for these functions, we have to call for this CartoPy feature object. If you call for this CartoPy feature object, you can like load these extra additional features. So to load those features, you need to load CartoPy features as CF features, and then you can import NumPy because I am going to create some sample data. That's why I am loading NumPy. So from here I am setting the central latitude as 37.5 degrees, central longitude as minus 39 degrees, and then I am setting the extent. For the extent I am creating it as a list. So this is the first longitude, second longitude, first latitude, second latitude. So now I am creating the bounding box. So this will be my area that I am going to set this one. And then I am saying, okay, central longitude, NP mean, then extend 2. So from here, get me the longitude's value from first two elements. In between first two elements, create a central longitude array, and then for the latitudes, create some sample values using these two values. So if I display this, execute this one, it should create two different arrays. So if I check for these two arrays, central lon and central lat, here I have a value between these two numbers. So if you get a value in between this one, you can get the central longitude, and then you can get the value of central value from here using the mean, because here I am using the mean comma. So we discussed whenever we type NP mean, that means it will calculate the mean of the values that we are going to pass. In here I am saying extend. We discussed about this one, you know. Now extend is the NP array type data, and now we are doing the indexing in here. During the NumPy array, I say we can do the indexing. So whenever we need to index, if we do something like this, what will happen? It will get the first two values. If we do something like this, it will focus on the last two values. So now for here, it is focusing on the last, not the last one. This one will focus on the first two values. This one will focus on the last two values. So omit last two values, get the first two values. So now it will get these two values and get the mean. Add them together and divide, then the value will be 95. And for the same thing in here, for the central latitude. So this is what if you didn't know about the central longitude and latitude. Last time in here I didn't assign the central latitude and longitude, no. So I also can do the same calculation if I need to center my thing on the center of the map or the drawing area. So now I am doing that calculation and getting the central latitude and longitude. This is an additional thing, and then we are calling for figure. So in figure size, what we are setting, this one is 12 inch in width and 6 inch in height. And then we are calling for the AX. Then plot axis, we are setting the projection as Albert equals area, and then we are setting this one as the center. So we discussed this one, how to set the projection for this one. What will happen? Now plot axes will be converted from typical axes to geographic axes when we are setting this one, and then we are setting the extent to be in this format, and then we are setting, okay, we call for add features. So we can call ax dot add features. This is an inbuilt function, and then we can call for the features that we need to display. From CartoPy features, we can call for oceans. So if we like load CartoPy features like CF features, we can directly call for this one, CF features open, because we already import this one in here. So either we can type the entire thing, or we can call for CF features dot ocean. So now ocean layer should be added into the map. And then the second one I am asking feature land. So land area should be added into the map, and I am setting the edge color. That means for land areas, mark the edge color in black color, and then I am calling for lakes. For the lakes also, mark the edges of the lake in black color, and then add features, add all the rivers, and then display the grid lines. So what will happen? I will get a map for the area that I am focusing on. From here you can see now it is downloading some additional data if the data is not cached in your PC. So it will automatically download these files from the Natural Earth website, and it will take some time to display. After some time it will display the data. So all of the other additional packages it is downloading. First it downloaded ocean and then river lakes. For the rest of the data I have cached. Otherwise, if this is first time for you to run, then all of these features will download. Now you can see, because in this command I said, if I delete this one, what will happen? Let me delete this edge color. So if I delete the edge color, what will happen? I am deleting the edge color of the land. So now you can see these edges have been removed. But for the lakes inside of US, in here we are focusing on the US, you can see the boundaries has been marked in black color. So if I don't need the lakes, I don't need to call for this function. So if I didn't call this one, what will happen? Only the land areas will be there, and you can see river lines are also there. If I don't need rivers, I can do this one as well. So if I come in, there will be no rivers. But if I need to add these kind of any sort of features, I can add. And if I need to do some sort of small customizations like adding edge colors, I can set it like this. So even if you need to go with random color, in here you can set some random colors. You can call for color code. If you need to be at the like edge colors in red, you can assign color as red. If you assign the color red, now it will be in red color. So this is these are some additional features which you can download, and then so this is the place where we are getting the data. So from here, if you go to here, you can see we have some free data sets. So if you go into the download section, you will see we have shape files in these scales. For large scale data 1 to 10 meter, and then 1 to 50 meter, and then 1 to 110 meter. This is the place we are getting that data for our map. So even you can manually download these files from this directory. So here you can see if you need to download, you can download this one directly as a shape file format. So the total area will be in 576 MB. So if you need to manually download this one, you can call for this physical player and download it in the same way. But in this case, we are setting it as like a separate variable. So in this case, we are downloading CF feature, natural earth feature, download river lake and center lines, and river lake center lines, because in here if I go into the natural earth website, in the features, so if I let me copy this one, river lake center lines. So it is downloading these features. So here you can see we have river and lake center line. So it is the attribute data of lake rivers, which is like creating a center line, not the entire lake like river. If we take a river, it should like flow like this, no? But if we take the center line, it will create the center point of these two edges of the river and create a center line to denote that river. So we are downloading that data from natural earth. So whenever you need to download some additional features, you can call for this one, because in natural earth we have some other areas as well. If you need to focus on Antarctic ice levels, you can download this data as well from this website directly. So you don't need to import it separately as a shapefile. You can directly download. If you see like some other additional features that you need to add, coral reefs and some other things, you can download. So here the main thing is you need to call for CF feature. That means the main thing in here we import CartoPy features. So from that library we have natural earth feature function. So if you use the doc string, you can see it is a simple interface to natural earth shapefile. So whenever you need to access the shapefiles in this natural earth data, you can call for this function, and then you have to set these few parameters. First you have to set the category, what category you need the data, and then the name of that category. So here I am focusing for physical. So this is the physical data section. So if I need for this category, if I am focusing on cultural vector data, then I have to type cultural. So I can access any feature in here. So in here you can see we have some admin, provinces and other things. Last time I say for United States we have option called states. But for our countries we only have country boundary layer only. But if we need to go for some subdivisional areas, we can call for cultural and then call for this first order admin. So if we call for the admins, then we can see the provinces and sub departments and sub areas in our countries as well. This is like default option. If that thing is not correct, then you can load the shape file. Whenever you need to access these files, you need to call for the group first, and then you need to call for your variable, and then you can call for the resolution. Here how many, what kind of resolutions that we have? 110 and then 50 and then 10. In this case I am loading 50, so it will download the data automatically, and then from there rest of the things are same. Here I am creating the figure, and then here I am setting the axes to be in this format and setting the center point for my map, and then setting the extent, and then adding the feature. You need to like focus on the structure in here. So if you understand the structure, what is the structure of plotting? First, we need to do any sort of thing. If we going to like plot some data, we need to do the calculation at the very top, and then we need to create the figure to plot the data, and then we have to set the axis, and then we have to set the extent. After that we can load any other features that we are going to load. Even our data we can like load in here. We will discuss how to load the data in the later part. This is to understand the code and the things. So from here we are loading CartoPy feature ocean and then land, and last in here I am displaying my own data which I download from natural earth. In here I download the natural earth data. River 50 meter is the variable, so I am setting river 50 meter, then the face color none, and then edge color as blue. So it should also display me rivers in blue color. So here I am saying ocean and then land. Now I can see rivers in blue color. So now we are going to add the data into the map. Now you know how to set the things in the map, inside the map. Now how we can add the data. So in this case, we are going to create some sample data. So we will create 2 points. So here we are creating the dictionary type data, because in dictionary type data I mentioned first we need to give the dictionary and then 2 quotes, and then I need to give the value. Then I can put the comma, and then I can put the name, and then 2 values, and then I can put the value. Likewise I can pass. So here I am going to create a dictionary type data for the new view. For the center point I can create, okay, longitude is this one, and then latitude is this one. So it will create two dictionary type data, and I am creating for Honolulu, I am creating these two center points. So what I am going to do is I am going to create 2 points in a map, and I am going to draw a line in the map. So how we can like draw these 2 points and make a line in the map. So right now I have 2 points in the map, and then I will say longitude New York loan. What will happen in this command we discussed? Now I am accessing, this is the dictionary. From that dictionary I am accessing the value of this specific key. So New York longitude, so it should get this value, and for Honolulu longitude it should access this value, and for New York latitude it should access this value, and Honolulu latitude it should access this value. What? So here, when you are specifying something like this, you don't need to type it in the same way, because I say in here, I am saying directly, I am converting this one into dictionary. So last time, how we create the dictionary data. So you can do the same thing, even if you like put 2 commas, it's also fine. This is also fine. This is also fine. This will also work. There are multiple ways, so it will also work. So what is the issue? It is saying expression cannot contain assignment. So in here you cannot put this one, because I am calling for dictionary type data like directly in here. So that's why I cannot call, because I am converting this thing into dictionary directly, because here I am creating an array and then I am passing it, like converting it into dictionary type data. Whenever you need to convert some data into dictionary type, you can type DICT, and within the brackets you can pass the data. If you pass, if you pass data like that format, then it will convert it to dictionary type data automatically, because in here if I execute this one and check on the variables using this debugging icon, I can see these two. I should be able to see these 2 variables over there. So you can see New York is DICT, that means the dictionary type data value, the key value is longitude and key value is latitude. These are the 2 values representing these 2 keys. So now how we can put those 2 points in the map? Okay, now we created the longitudes and latitudes. So now how we can plot these things? So in here, same thing, I am setting the axis as cylindrical projection system, and then AX plot. You know about this command. Whenever you need to plot something in using matplotlib, you have to use the plot command. But here, what is where it is like changed? In here, I did mention that this is the projection type. So if I say transform CRSS to geodetic, then it understands this plot function from matplotlib, like matplot library. It understands, okay, now I am focusing on a coordinate system, that means spatial data. So that's why I am putting this transform command. If I put this transform command, then it automatically understands this as a point, like a geographic point. Then how to plot the data is, first I need to give x values, and then I have to give y values. We discussed this one in the matplotlib. This is not CartoPy, this is actually matplotlib. So when you create a plot, first you need to give x values, then y values, and we discuss whenever we need to label something, we can call for label function and label that thing. So first thing, we are selecting equilateral straight line. So this will create the line, and then I am transforming this one into geodetic. So there should be like 2 lines. So if I execute, rest of the things is to add coastlines and add legend and set the global command. That means show me the entire command. So here you will see 2 different maps, 2 different lines. One is rectangular straight line, and the other one is great circle, because you know, if we check on 2 points on the map, it is not like straight line. It is not a straight line. Actually, it should be a curved line. because you know our globe is like we consider Earth as a globe, not as a flat map. So if we are converting it into a flat map, what will happen? Just imagine in the globe, if we have a straight line and we are trying to like flatten it, so it will automatically be a curved line. If you flat that's why we see this curved line in here. So now how we can plot 2D raster data. Last time in here we discussed about one dimension data, how to plot like single points or line. So now how we can plot raster data. So when we are plotting raster data, how we can plot the raster data. For this one, we will create some sample data using the NumPy, same thing. Here, what we are doing, line space between these two values, create random 25 values. And then, because line space and arrange function we discuss when we are discussing about NumPy. So here also we are creating some random latitude. So we are creating between these two values, create me 25 values, equally spaced 25 values array. So now I will have 25 values for longitude and 25 values for latitude. So now if I say 25 values for latitudes and 25 values for longitude, what will happen? Now I am creating a grid. So just imagine a box like this. So for this box, I am saying latitudes I have 25 values. So it will create this kind of lines in the data. And then for the longitudes, I have 25 like this. And then for the latitudes also, I have 25 values like this. Now what I have a grid. I have a grid. When I discuss about the X-ray, I said we have this kind of grids stored like in multiple tables. Whenever we going to display about the raster data. In raster, for this one cell we are calling as the resolution. So now I have that grid. I am creating a temporary mesh grid layer by using this mesh grid command. So now it is creating this grid for longitude 2D and latitude 2D. Now it is creating a mesh grid like this. Now for this mesh grid, I need to fill each of these grid values using this command. Now I am setting like, okay, data NP cost, fill these each cells using these random values. So it will fill these values and create me a data set like this. Now how I can plot these two data? Same thing, contour F. So what contour F mean? So when I discuss about the PLT function, I say we have different kind of plots in matplotlib. So if you go into the matplotlib, matplotlib pyplot documentation, here you will see different type of maps that we can use. In here we have a map type called contour F. So you see, we have one map called contour F. Now we are calling for contour F. If you are calling for contour F, what will happen from here? It will filled contours, create filled contours. That means it will create something like this. If you know about the Earth data, when we are displaying sea level pressures in our map, you will see in some maps like the sea level maps. Let me load the map in here so you can understand. So this kind of lines. So if you need to display this kind of lines, these are called contour lines. So these represent like pressure values. In this case, each line representing a pressure value. So if you need to create this kind of map, you have to call for contour f function. So if you go into the documentation in here, it is saying you have to pass x and y in array format. And then if you have C values, that means you can create three-dimensional contour plots as well. Then you can put the C values as well. And then you have to pass your levels. And even if you scroll down, you will see some examples as well how to plot a contour plot. In here, I am creating a simple contour plot, and then I am passing x and y values, and then I am passing my actual data. So this is the x values, and this is the y values, and then this is the actual data. Because when we are going for plot in PyPlot, we just need to pass x, y, that's it. But if you are focusing on contour f, we need to first pass x-axis, then y-axis, and then we have to pass the actual data. If it is three-dimensional, we need to assign all the three axes, and then we have to pass the data. If we use contour f, so I am passing longitude values, latitude values, and then the actual data value. So if I pass something like this, then I can see a contour map like this. So you see the values, because in here I say I need latitudes to be in 30 and 70, 25 values equally spaced. So latitude values is ranging from 30 to 70, and longitude values are ranging from -80 to +80. So in here it is doing some random calculation and filling these values. So these are the values that I ended up with. And then how I can plot this data in a map. So now this command, now I am setting the plot and setting the axes to be in this format, and then I am setting the extender to be like display the global map, and then display the coastlines, and then I am asking AX contour F, plot this data, longitude, latitude, and then data. So now it will automatically plot the data in the map. So if I execute this one, it should give me a map like this. So what will happen if I remove this coastline? Now you will understand why we are putting this coastline. So we will see a map like this, but we don't know which areas this one is representing, because we are what we call these axes are not labeled. We don't have major tick marks and minor tick marks till now. So if we turn on this one, we can have a rough idea, okay, where this data is focusing on. And now what if we need to plot the same data in a different map format? So if we plot this one in a rotated pole, what will happen? Rotated pole mean what kind of map? So if we rotate the south pole and north pole, in our typical maps, our north pole is in this side and south pole in this side. So if we call for rotated pole, what will happen? It will rotate the map in this way. So our north pole will be in here and south pole will be in here. So no, it's on other side, another way, no? This one is like north pole and this one is our south pole. Because from the map you can see, now the north pole and south pole is being shifted. But actual value is not changed, because here you can see still the location of these values is in the same place, but it doesn't shifted the values accordingly. Because if I shift the values, where should it range from? It should go from part of this area in the US to part of this area in the southern Asia. So those values should range from like this in this area, but actually it is not displaying the values correctly. So where did I make the mistake? So when I am saying something, doing something like this, I have to set the transformation for this one. Contour F also I need to set, because contour F is coming from matplotlib. It is not from CartoPy. So it doesn't understand what kind of data is this. So to this function, I need to say this is also a geographic data. Just focus on the geographic data and go with this projection type. So how I can set that function? We discuss about transform when we are discussing in here. Because in this plot function, we say, okay, transform this one into this data format. CCRS geodetic. So we need to do the same thing in here. So if we set, because in this command we didn't set this one, that's why we are getting an error when plotting the data. Now if we set this transformation function in here, in this time I am saying just go for the cylindrical plot type and transform the data accordingly. I am just specifying it in here. So if I clear the output in here, let me clear the output so we can see those two functions closely. So rest of the functions are same, but in here it is different. So if I run this one, now what happened? So now it understands, okay, even though I use a matplotlib function control F, it recognizes, okay, these values needs to be in this coordinate system. So now it understands, okay, this is the coordinate system I need to use, and these are the longitude values and latitude values. So it is automatically putting the data according to the actual area. So now next one, how we can display some maps in the CartoPy area. So if we need to plot a hurricane or some image that we need to have display over the map, so how we can do? So this is a simple wget command. If you guys are familiar with wget in Python, we are using wget to download some data from the URL if we need. So if you go here and copy this one and open, what will happen? This is a typical web link. So let me copy this one and open it separately. So if I open this one in a separate window, I should get a image. So now what we are going to do is we are going to overlay this hurricane image inside the CartoPy, because this is the image in the website. So you can see the website, and it is in the image format JPG. So now how we can overlay this kind of maps in our map? So first thing is you need to download this data. So what this command is doing is it is downloading the data from that URL. So if you guys also facing this problem, that means wget is not recognized internal or external command. That means wget is not installed in your Honda environment. So how we can install this one? You have to go back into your terminal here, and then you have to terminate the session, and then you can install wget. So there's another command that you can use. You can use pip to install these things as well. Pip is also the same. It is also coming with Python inbuilt. You can use pip install wget as well. If you get package not found in or like issue, then you have to specifically for say okay, search for in Conda Forge. If you type Conda Forge, then it will install. Otherwise, you have to type this command. Specifically saying okay, focus on Conda Forge and install this Python wget. So else you can download the image and then we can display it over there directly. I said you send you the image, send the image into the group. So I will terminate this one and show you another method that you can install these libraries if it is missing. Because we don't need to terminate the Jupyter Notebook. Actually, we can like install these libraries by using the Jupyter Notebook as well. So whenever you need to install a library using the Jupyter Notebook, let me show you the command. So now I load the Jupyter Lab. So now I know I don't have this wget installed. So how I can install wget? So in here I can type using this exclamation mark at the first, I can type pip install wget. And if I run this cell, no, pip is default, like by default it is installed. If it is Python environment, it is like already over there. Don't need to install. See, now it is downloading and now it is installed. So now if I run this command, if it is still saying the command is not recognized, that means we need to restart our kernel. So from here I can restart the kernel. And then try to run that live. So still it is saying not recognized. You can directly download the file from there. So let me share you the URL. You can download the file from there. Because last time I was trying to download wget from there, so maybe it was confused what to do. You can download the image from this web link, or you can download it, save that image in your directory. So here I have that image in the same location where I have my script file. So now I will load this image. How to load the image is, I will say, okay, my file name is this image name. So you can see the exact name, otherwise you can copy. You can click on rename and copy this image name and paste over here. So now I am saying, okay, display this image, and then for the image extent, for these things, you need to know about the actual extent of this image. That means the starting longitude, Indian longitude, and then starting latitude and Indian latitude. So you need to know about these dimensions of that image. So in this case, this was mentioned over there in their website. So I get that values from here. So that means here it will be the starting latitude in this area. This corner, it will be the starting latitude. So the website which I get this file, they mentioned over there, this is the extent of this image. So this is the longitude 1, and this is lon 2, and this one is latitude 1, and this is, in this corner you have the latitude 2. So if you know these values, in this case I know the values, so you can specify those corner values, and then you can say img equal plot img read fname. So imread is the function whenever you need to read an image. Now this function will read the image. So it will store in the img variable name. So now I am saying, okay, plot axis, this is the projection type, and then set margin to be 0.05, y margin to be 0.01, because I am going to plot an image. So when plotting the image, put a margin between the area, like actual map area, and the image. So this will be the margins for x-axis and y-axis respectively. And then I am calling axis im show to show this image, and then origin should be from the start, like upper point, starting point, and then the extent of this image is this is the extent of that image, and then transform this one also into this coordinate system. So imread is also a function in MATLAB. It will also understand, okay, I am going to plot an image, but this image is also have an latitude and longitude extents. So plot this image according to the format that I specified, and then display the coastlines, and then plot. This one needs to plot an area. So if I need to plot a specific area, I can give the x value, y value, and then the marker type and the marker size and the label for the marker. Then I can add the text for this specific latitude, add text San Diego, and then transform it also into the coordinate system. So if I run this one, now I should get an error because I didn't import PLT. Because I restart the kernel, so it is giving me an error because I restart the kernel. From here you see this is the number 3. So this is my number 1, this is number 2, this is number 3. Nowhere I didn't import PLT. So that's why it is giving me an error. So what I need to do is I need to go up where I import matplotlib as PLT. So here I am importing this one. I can run this command and then go back over there. So now CCRS is not there because I didn't run this script, this part. So I will run that part and then run this one. So errors will go away, and then I can go down into the script and then run that specific part in the code. So if I run this one, now it should work because all the necessary libraries were loaded. So now if you see, you can even load the image files along with the coastlines. So this is a hurricane we were about to hit to this San Diego coastline. So now how we can read the data from NetCDF files. So this is the other important thing. Now you know how to set the extent and everything, how we can like read the NetCDF file and plot some data on the map. So in this command, what we are going to do is we are going to access directly data from the URLs. We are not going to download any data. So in this data, NOAA, they have their trade server. I discussed about this one yesterday. They have their own trade server, but the problem is sometimes their data will be there. Sometimes they are like removing the data and like replacing it with new data. So over here, if you go into the trades documentation, you see you can download files using the HTTP server. So now we are using the HTTP protocol in here and accessing the data file. That means NOAA ERA5 dataset SST in the mean value file. We will try to download this NetCDF file in this link and we will open it using XR open dataset. So when we are opening the dataset, we need to provide the URL. If it is like locally stored in our PC, we need to give the path. And then we have to say engine. In here, I am not going to specify the engine. If you didn't specify the engine, it will go with the accurate engine which can like read your dataset. Otherwise, you can directly specify read this dataset according to this engine, because last time we discussed how you can set the engine. When you are setting the engine, you can set engine equal, if it is an NetCDF file, within two brackets you have to type NetCDF4. If it is in NetCDF4, then you have to type NetCDF4. If it is like grid data, then you have to type GRIB. If it is like HDF5, then you have to type HDF5. These are like some engines that they can read the data. So now I am asking, open the data set from this URL. Over there's a variable named time bands. Just drop the time band when reading the data. So we discussed about the drop command. So when you are reading the data, you can directly drop some columns as well, because if you view the doc string in here, you can see what are the functions that it is accepting. So if you run this one, it will take some time because it is going to access the data in this URL and download it into your PC. And open that XR file, because we need to discuss that XR. Like yesterday, we didn't discuss about how to plot the data after reading the XR dataset. We will go with that thing because we need to in the training today. Otherwise, it will take some time. So now you can see data is read from that URL, stored in that URL. It is downloaded the data, and then it is showing us the data set. Because when I discussing about the X-array, I say we have data set. So from the data set, you can see the dimension. We have for time, we have 258. And then for the latitude levels, we have 89, longitude level 180. So if I check in here to check whether this is global data or local data, I think this is global data because it is ranging from 88 to 89 latitudes, and then for the longitudes it is ranging from 0 to 360. So that's why I say sometimes your longitudes will range from 180 to minus 180. Sometimes your longitudes will range from 0 to 360. So you have to check for these things after loading your data. And for the time, the starting time is 1854, January 1st till 2025, That means last month, 6th of June, we have the data. So now this is like mean temperature, I think. So if we go for the variable SST, so that means this is the data for sea surface temperature. If I go for the attribute table, I can see the data provider who is like who created this data. So who's the provider of this data and some other additional features in here. So latitude is representing degrees north, longitude is representing degrees east, and then which kind of grid and history plus some kind of additional metadata will be over there. So now how we can plot the data. So after reading the data set, you know what are the variable and what are the dimensions that we have. Yesterday, when we are discussing X-array, I told you how we can select the data. So in this command, what we are doing, ds.sst, what will happen? What I am saying in here, ds.sst, I am saying go for the data set and then select variable sst. Now what will happen? It will select all of these values in here. So all the values are in monthly means of sea surface temperature, and it will select these values. And from there, I am saying I just don't need the all value. I don't need all the values. Select this specific time. That means for 2000 January 1st, and go for the method nearest. We discuss about this one. If we type nearest, what will happen? If the data is like date is not accurate, what will happen? It will check for the closest date, and from there I discuss on that day we can set the plus and minus. So the range that I need to check for. Tolerance. So we can set the tolerance. In here I am not setting the tolerance. So what will happen? It will check the closest date for this day that I am specifying. Then I am discussing this one we discussed about the matplotlib. So we discussed how to create a figure. So this is creating a figure 9 inch by 6 inch. And then I am saying, okay, this is from CartoPy. I am saying set this axis in the plot from typical axis into a geographical axis, and this time I need that axis to be in Robinson coordinate system, projection system. And then I am saying, okay, turn on the coastlines and then turn on the grid lines, and then I am calling, okay, sst.plot. So I am calling for sst directly, and then I am calling for the plot function. So axis where this data is going to plot is same axis or the same subplot that we created as AX, and then I need to transform this data into the plate carrier projection system, that means flat like cylindrical projection system, and then minimum value and then the maximum value that I need to display in my color bar, and then color bar keywords, shrink the color bar to be 0.4. So now what will happen? If I didn't mention these things, what will happen? It will display the data. Just imagine if I delete this line, now it should be displayed the data according to the things that I have given. So now it is like to start reading the data set. So it will try to find the exact time. So now it find the time frame 2000 January 1. So this is the mean surface temperature for that value. Now to format these things, this one, so you can see in here our values are ranging from -30 to +30. But I only need to like display these values between 2 to 3. How I can set this, like the range of this color bar? To set the range of color bar, we have the additional options in here. If I check for this function, it is saying these are the additional functions that I can go with. Subplot keyword. So here, when you are setting the additional functions, these are some additional functions. So if you set vmin, this is an inbuilt function you cannot change, but value you can change. If I set vmin to be 2 and vmax to be 30, what will happen? Now the color bar will shrink. So like this C bar will display values from 2 to 30. And then I am saying shrink the color bar to be bit small. Right now it is going from the actual height. In here I mentioned 6. So it is go for the starting point to index point. So this one will be like 6 inches. So now I need to shrink that thing into like half of the resolution. So if I execute this one, what will happen? Color bar will be adjusted into the range that I mentioned in here, and then the color bar will be shrink. Now you can see this one has been shrinked. So how I can increase this one? If I need to increase it a bit more, I have to change it in here. If I type 6, it will make that color bar a little bit bigger. So you can see. So how we can like display the mean temperature in here if I need to display the mean values. So right now I am displaying a one single value. So I am loading this data. So if I need to display the latest value, how I can go? From here I know you can go for the dates. So you can go for the indexes, data variable no, indexes. If you go for the indexes, from here if you check for time, you can check the latest time value. So if I need to display this data, what I can do? I just need to copy this date over here and paste it over there. So what will happen? It will display me the latest sea surface temperature mean for the previous month. So now how you can set this one? We discussed. So if I in here I am going for Robinson coordinate system. I don't need this one to be Robinson coordinate system. If I need to this one to be in flat map, how I can change this one? I will change this one into and run this one. What will happen? Now map is changed. So now if I need to focus on a specific area, I need to set the extent. We discuss how to set the extent, how we can set the extent for the map. We discuss about this one, how we can set the extent. At the top we discuss how we are setting the extent. In here we say extend, you can give this one and then you can ax dot set extend. These are the two lines that you need. You can either copy this one or paste it over there if you are focusing on a specific region. So that's why I discussed these things earlier. So let me paste this one in here. For extend, I need to specify the extend at the top where I am doing this filtration. I will set, okay, this is the extend and I don't need this line because I already mentioned it over there. And now I need to set the extend. So if I set the extend, what will happen now? So now it is focusing only on the extent that I mentioned. So that's how you can like do some modification. So if I need to get the mean value, how I can calculate the mean of this data set? So now we will discuss about some practical examples. Yesterday I put one file into the group. No, this file I think I put this one in the group. So you can open this file. I think I put this file, and if you download the data, you need to download the data as well. Because in here we are loading NumPy, Xarray, Matplotlib, and all the necessary data files. So did I send you this file or something else? Did I send you guys this file? So if you don't have the data set for this file, you can download this one. Let me like share you this script. So you can download that script file. So we will discuss how we can go with practical scenarios when we like all by using this all the libraries that we discussed earlier. So you can load this one. For this one, I think you don't need any data to be downloaded. All the data I think you can access. Yeah, this data you can access without any issue. No, this is the script that I have shared yesterday, I think this script you guys have 0.3 data visualization. This script you guys have, no? If you did you guys download these two data files which I have sent in the group at the beginning of the today's class? These two data files, did you guys download these two data files? So if you have downloaded that data file, you can save those data files in the same place where you save the script. Because this is the practical thing, like how you can use this data to do some practical calculation. The libraries that we learned, these libraries are necessary for lot of calculations that you guys are going to do. There are some other additional libraries, but with the time we don't have that much time. Otherwise, we will have to extend the trade. If you guys are okay, then we can extend. Because now we need to discuss about some practical things. So now you should be able to have this script file and these two data files in the same directory. If you have this one, then we can continue. This is like the X-ray tutorial that we tried to discuss yesterday. Because of the data links in here have been changed. That's why I couldn't download, but I have found now new links for this one. Since last time it is coming from thread server, this time I found another server from for this CMIP data, because in here we are using some model predicted data to do some visualization. So these are you can see historical CESM2 mean a model. So if you check for CESM2, SM2 is a model. So if you check for this one, it is a model, community earth system model 2. So this is they are simulating the temperature and different kind of scenarios in atmosphere, like precipitation, how it will change for up to next 100 years or so. They are doing the simulation. So we are accessing a historical simulation, because we don't have the historical data, because we have some if we are focusing globally. For global, some of the countries, even their meteorological offices are open after 1950 or so. But we don't have the early data. If we need 990, 80 or so, we don't have that much data. So how we can get the data? So they do the historical prediction. So in our case, we are using the historical prediction data. So this is the model and this is the variable. So this one will be TA, this one is TAS. So this is the simulation, and this is the model number, and this is the historical data, and this one we call the ensemble member, or what kind of scenario that they have simulate this data for. So now we will try to load this data. So how we can load this data? First thing we discussed, we need to import X-array when we are dealing with NetCDF type data. So we will import the XR as X-array as XR. Now we need to specify the data set, and in here we are using XR open data set. Last time I used, when we are discussing about the CartoPy, in here we also use the same command, open data set. But in here what we have done, we directly call for the data in a server. But this time in this script, what we are going to do is we are going to use the data which is stored locally in our PC. So now in here you have to give the path of your data set. So now if your data is in your current directory, what should be the command in here? So you have to delete this one. So if you go with this one, what will happen? It will try to search for data file, data folder in your current location. Now if your file is over here, we have to change this one. We don't need to access the root and check for the folder. Just check for the file. Otherwise, if you type the command, what should be the command? So here first we will load the TAS dataset. So what should be the command? I can type TAS and hit tab. So it will give me the available dataset in that directory. So if I have a folder, I also have a folder in here. In folder also I have some data. So if I need to check for the folder, how I can check for the folder? slash dash. So then it will show me all the files available in that directory. Then I can type DA. If I type data, you can see it is saying this is a path. Now if I hit tab, it is showing me all the data files which are stored in this data folder. So that's how you can set your path for specific data set. So in here we will we will try to load this TAS data, and then we are specifying, okay, load this data set in the NetCDF for data engine. So now after loading, just display me this data set. So it will take some time. After taking some time, it is showing me the data set. For here also you will see we have how many dimensions? We have 4 dimensions. We have times, latitudes, longitudes, and then ND, BD, NBD, NB, ND named variables. So if we discuss about this one, if I extend this one, I can see TA is mean 2 meter air temperature, frequency is monthly, and the variable ID is TAS, and long name near surface temperature. You can see some other values, even the units and everything. So now how we can read this data and go with plot. So if we need to plot this data, how we can go with a simple plot. So we discuss about this one, DES, TAS, then select. We discuss now what in this part what it is doing, because in here I load this data set into a variable named DS. So whenever I need to access a data like a variable in that data set, I can call DS dot then my variable name. Then I am loading the entire data set here. After that I am asking dot select. So now it is going to select the data according to the parameters that I am going to set. Now I am going to set, because now we are going to create a line plot. Simple 1D line plot. So we need to select one latitude and one longitude if we are going for a time series plot. If we set like multiple latitudes and longitudes, what will happen? The data will be like sliced. But here I am specifying, okay, focus on this latitude and this longitude, and then search for the nearest method, and then go with the plot. So we don't need to like load the matplotlib directly. So if we call plot, there's an inbuilt command inside this X-array dataset as well. So it will simply display the variable. So this one will come handy when you need to check the data. But for the plotting, you cannot do a lot of customizations in here. That's why we need to go with matplotlib. This is just to check the data. If you run this one, you will get an error. So why we are getting an error is we don't have one package in here, CF time date type. That's why we are getting this error. So we need to install this package first. After installing this one, we can go ahead. So what should be the command for this one? So it is saying we are missing one parameter called what we call CF time and date. So you can check for this one in the web. You can check for this error in the web. So see, you are not the only one who is getting this error previously. So they are, if you go here, they will mention what is the issue. So what is the issue? You don't have this variable. So here if you go, they are saying you need to pip install NC time axis. So now you know how to run this pip command. You can copy this one, pip install NC time axis, and then let me share you this is like this file over there in the group as well. So you need to run this command to install this missing library. So how I can install that missing library? I can create a new cell in here. So now it started like downloading all the necessary files. And now if we try to run, still if you receive the error, you have to restart the kernel. After restarting, you can load the data again, because we have to load the data again after we restart kernel for like installation of some data or anything. We have to run the script again. So you don't need to run this command because we already installed that one in our library. So we can skip that part and continue with this one. So now you can see it is displaying us the plot. So now we are focusing on this specific latitude and longitude and asking it to plot all the time values over there. So now it is displaying the values from 2000 to 2014, because if we check the dates or the time in here in our data set, you can see times are ranging from 2000 to 2014. We have monthly values, so it should display all the values in our time series, because we are asking to plot that specific point. So it plot the values for that specific point, like monthly values. You will see like 12 plot points for this one. So how the temperature is varying. So from here you can have a rough idea. We are discussing about global warming. Can you see a pattern in here? So you can see these peaks. That means these peaks should represent the summertime in this specific point. So now if you focus, it is like keep increasing. So you can see that's why we say like temperatures keep increasing. Like even the minimum temperature for that year in this like 2010, it was around this value. But right now the minimum temperature is also increased. So you have some rough idea. So now how we can slice the data. Now we are going to slice the data. How we can slice? Yesterday I discussed about this one when we are discussing about X-array. We have a command called slice. So now what in this command what I am saying ds select TAS variable, and from there select variable time, and then now I need to slice. So now what will happen? I am saying slice the time between this and this. So what will happen? Get a specific time frame. In this case, I should end up with one value, because I know my data is monthly. So if I type something like this for the TAS, what should I get at the end? I should get one time frame, all the latitudes and all the longitudes. So now if I need to display like, okay, now I need to display how the values are varying in these latitudes, how the values are varying in the different latitudes. So I will check on these three. I will focus on these three latitudes: 0, then minus 40, and then positive 40. Now I need to check how the values in these different latitudes are varying. So how I can check this one? If I type this command, now it is going to select the data from TAS variable. Over there I only have one time dimension. Now I am asking to select these latitude levels, and then method will be nearest. If these latitudes are not there, just go for the nearest latitude and select the values, and then plot it accordingly. And for the x-axis, it will be longitude. So after we reduce the time dimension latitude, what will we end up with? We will end up with longitude. So now we are going to check for each latitude level how the temperature is varying with the longitude. So if we display something like this, for the hue I am saying as latitudes, and then figure size to be 8 by 6. So now if I execute this one, I should get like 3 different points. So here you can check for these 3 latitude levels now how the values are varying, how the temperature is varying. Temperature is varying in different longitudes. So in the center point you can see how it is varying, 0 degrees. So it is varying like this. And then in the what we call northern part, temperature is varying like this, 40 degree latitude, and then minus 40 degree latitude, how the temperature is varying, and in the equator, how it is varying. 0.47 is represented by this color, because we know we have the highest temperature in, where we have the highest temperature in the, if we focus on entire globe, we consider a map like 0 and then 90 and then minus 90, and then from here we will have 0 to 360. Let's imagine from 0 to 360. So if this is Earth, where we have the highest concentration of solar radiation. So if you consider this one, you don't need to think that much. If this is the sun and this is the Earth, so closer places in the Earth is 0, because here we have the 0 latitude, here we have the 90, and here we have minus 90. So closest point to the sun is 0 degrees latitude. So we need to have highest temperature values for 0 latitude. So if you check, it is true, we have the highest Kelvin values for 0 degrees. And if we focus on minus 40, we have higher values compared to the other part. Why? Why we are having these kind of values? What is the date that I am focusing on? The date that I am focusing on is 2013 March. So in March, which side is like, we know Earth has a tilt. So in the North Pole, we have summer in which time we have the summer? August. Like in the North Pole, if we have summer, we have the time in which time frame?